Hello everyone, and welcome to day 2, looking at derivatives of trig functions. Just a few things to look here at. The derivative of sine is cosine. The derivative of cosine is negative sine. One of the ways we remember this is we look at the c. C means to change the sign for derivatives. So one thing to remember there. Tangent is secant squared x. Secant is secant tan x. These are the 4 that you really need to know. This is going to help you on the AP test or any calculus test. These 2, not so much for my class. Cotangent is negative cosecant squared x, and cosecant is negative cosecant x. One of the things to remember or look at here is C. And C, they start with the C, they change the sign. Other important facts, we all know this, is tan is sine over cosine. We've got some identities here, and the double angle formula, sine 2x equals 2 sine x cosine x. This is the Pythagorean identity right there. So, excuse me. Find the derivative of 4 tan x. Remember that the 4 is a constant, so that can just stay. 4, the derivative of tan x is secant squared x. And you're done. That's it. 6 cosecant x, go up here, cosecant x negative cotangent x cosecant x, so put the negative there, cotan x, cosecant x. And for the last one, sine x, cosine x, notice that this is being multiplied, we got a product here, and so therefore what we're going to do is the product rule. Now I showed you a couple ways to do this last time, but we got cosine x here, negative sine x here. So with that, you're going to take the first sine x multiplied by the derivative of the second times negative sine x plus the second cosine x times the derivative of the first cosine x. And therefore, what we get is negative sine squared x plus cosine squared x. Now know that that is not an identity. Negative sine squared x plus cosine squared x is not an identity. That's your answer. So this is how we write them. This is derivatives. This is the boring kind of just do it derivative way. So when we look at this, we got sine squared x. We have not learned the chain rule yet, so we need to rewrite this out as sine x multiplied by sine x. And therefore, when you take the derivative, and do the first, just like we did in the last example, times the derivative of the second, plus the second, times the derivative of the first. And what you notice here, you're going to get 2 of them. They're the same thing. So we're going to get 2 sine x, cosine x. Done. When we look at this one, change colors. I'm going to make this a little more exciting than it is. We have, again, 2 products here. 1, 2. And so when we write this down, notice that we always write f prime of x. We're going to get 2x, and I take the derivative first this time, times the second, secant x. That should not be like that. Plus the first, I just did it backwards than we're used to, times the derivative of secant x. Well, what's the derivative of secant x? Go down back here. Secant x is secant x tan x. As I said, you want to be able to memorize that. Secant x tan x. So what we get is basically that just rewritten out. It doesn't matter. Usually you would write x squared first just because it's got the higher power, but it does not matter. There's not a way to do it. Know that you could have also done this. Taken the x out, factored an x out. So you would have gotten x secant x tan x. Oh, sorry. You know what else we could have done? It's my fault. Factored out the secant x too. And so now what we're left with is x tan x plus 2. And sometimes professors will say that's the simpler answer. That's the answer. Both answers are correct. Okay, don't worry about that. Either one would have worked. This is helpful to see. factoring out can help to cancel or whatnot. So factoring, especially when solving the problem, it's better to see. But don't have to do that for this type of problem. The last two, just take the derivative ones. We got a quotient rule here. So again, we got low, d high. It's a derivative. Sometimes people like to do this. Take the derivative first just so that they know what they're doing. So low, d high, minus high, d low, all over low squared, which we can then write equals. So let's see here. We got 1 plus, we know that that needs to be in parentheses. So we got nothing you can factor out. So we're going to get cosine x plus cosine squared x plus sine squared x all over 1 plus cosine x squared. Now, key thing here. Notice what we got. We've got the identity function. So we're going to get cosine x plus 1 all over cosine x plus 1 squared. I just wrote it out so that you could see that. And those will cancel. So we're going to be left with that as our final answer. You have to know that's a Pythagorean identity. So we got cosine x plus 1. We had a 1 plus cosine x. Commutative property states that they're the same. We can cancel one of the factors out, and so we're left with 1 plus cosine x. Look at this one. Again, as I said, some people like to take the derivatives immediately, so we got cosine x, and we have negative cosine x for this one. Remember that all the constants, or the derivatives of any constant is 0, so just as a reminder of that. So f prime of x equals low 1 minus sine x, d high cosine x, minus low d high minus high, d low. That's getting really sloppy. Sorry, I'll try to get better for this one. Over 1 minus sine x squared. So why don't you guys just take a minute and simplify that and see what you get, and I will do the same. So pause it, simplify it, and then come back. And so hopefully you got 2 cosine x all divided by 1 minus sine x quantity squared. And so that's what you should get for the answer. So to finish off the notes, if you had any issues, pause it, look at what I did. Pretty straightforward though. Find the equation of the tangent line. So equation y minus y1 equals a parentheses x minus x1 of the tangent line. So you know this is the derivative. As soon as you see that, you get derivative of the function cosecant x when x is equal to pi over 4. So a few things that we need. We need a point, and we need the slope at x equals pi over 4. So how do we get the point? Well, we know that we need to find f of pi divided by 4, which equals cosecant of pi over 4. Well, what is cosecant? Cosecant is 1 over sine of pi over 4. Well, sine of pi over 4, we know is 45 degrees, so we know that this is really equal to 1 over square root of 2, which when we flip and multiply the denominator, you're just going to get square root of 2. And so that's what we've got. So the last thing that we need to do is find the slope. Well, to find the slope, we know that we need to take the derivative. So we need to find f prime of x, which we know is negative cosecant x, cosecant x. Can't read that. And so to find the slope at pi over 4, we're just going to plug in pi over 4.
I have a question.
So we've got negative cotan to be, or tangent of pi over 4, 45 degrees is 1, so you get negative 1. And cosecant is 1 over sine. Well, we know sine of pi over 4 is square root of 2 over 2, just like here. So we know that's square root of 2. And so we're going to get negative square root of 2. And so therefore the equation of the tangent line, the equation, is y minus square root of 2 equals negative square root of 2, parentheses, x minus pi over 4. And there it is. Your entire lesson on derivatives of trig functions the simple way. Just wait till we get to chain rule. Anyways, have a good day.